Hello, in this video we're going to talk about the application of the sinusoidal function. First, this is exercise. A point rotating around a circle of a radius of 3 centered at the origin. Find the equation of the fx, show the y-coordinate as the function of the angle rotation. What does that mean? It means you have a circle and you're going around it. So we can start the point at here, and then it will keep going. As the rotation continue to that way. I don't know why they won't let me draw this. Huh, that's weird. Okay, let's do this one then. And they want you to represent it as a function. Now let's take a look what's the changes as the angle rotated. So when at the here we have when x equals to, when they first started, when it equals to 0, the angle is 0. That's how they started. And then y is equal to 0. When they rotated to that part, the rotation is half pi. Y is equals to positive 3. At this point, y is equal to 0. At that point, y is equal to negative 3. So let's summarize it. So when fx equals to 0, when x equals 0, y also equals to 0. F of half a pi, we have pi over 2. Oh, no, sorry, 3. We got 3. And then when x rotated 118 degrees, which is pi, we have y back to 0. And if they rotate in another 19 degrees from 118 degrees, we got this equal to negative 3. And then f of 2 pi, they go back to 0. So when you look at this function, what do you think it is, sine or cosine? Since they started from 0, this is going to be a sine function, sine x. And since, what do you think the amplitude? Because usually sine function is in a unit circle, which means the radius is equal to 1. But right now the radius is equal to 3. So that means this is going to be amplitude 3 times. So that's our function. Fx equals to 3 times sine x. Okay, here's a second question. A weight is attached to a spring, which is hung from a ball, and the spring moves, and the position y to the ball ranged from negative 1 inches at the time 0 to negative 7 inches at the time pi, assuming that y is the cosine function. Well, first of all, they tell you that this is going to be a cosine function, and then they want you to graph the function and also find the fx, the equation. Now let's draw a graph. Let's say this is a ball, and you have a spring. At beginning, you attach to some mass. At beginning, here is negative 1 inches from the ball, so that means this part is negative 1, and then at the end they keep spinning, move to all the way here. It got extend or stretch the spring. You get to this part, and then this part is, the position here is negative 7 inches. Okay, so that's the idea. And during the spring, maybe the ball at some point at this part, after they go to the lowest point, it move up back to the top, just like how we see it. So that's the movement of the spring. Now let's draw this. If we're graphing this, usually we just graph it in one phase. That means before it repeats. Okay, we know that when it's, hold on, let me draw a better one. And then we know that it starts with -1 when the time started. That's the sprint, right? And then after pi time, this is going to be a -7 at pi. So that means the graph is going down to here. Since they tell you that this is going to be a cosine function, what do we expect? We expect that the graph will bouncing up back to the highest point, which is -1 at what time? Cosine function is symmetric on every half phase. Since from the highest point to the lowest point, that's considered one half phase. If we repeat them here back to the highest point, this should be what? Good guess, it's 2 pi. All right, so that's one phase. And then the rest, it just repeats. Okay, so that's the function. And now, how do we find the equation? Well, let's say the midnight, where's the midnight? The midnight is half of the highest point to the lowest point. Should be here, should equals to -4, right? So now we find the midnight is equal to -4. So that means D is equal to -4. What about the amplitude? Well, the amplitude is equal to half of the maximum subtract the minimum. So that gives you a 3. So that means the amplitude A is equal to 3. What's next? Phase. We know that they repeat every period. Period. Not phase shift. We do phase shift later. So the period is going to repeat every 2 pi, right? So the period is equal to 2 pi divided by b, and the period is equal to 2 pi, so that we can solve for b equals to 1. Next is the phase shift. They already give you the hint that this is going to be a cosine function, and then as you can see, they're starting at the highest point -1, which means there's no shift. So that means the shift is equal to 0, and then the phase shift is equal to c divided by b is equal to 0. And then we substitute b is equal to 1, then we solve for c is equal to 0. Now the sinusoidal function would be fx equals to a, which is 3 times cosine b. Our b is equal to 1, which is x, and then our c is equal to 0. That means we don't need to add anything, and then subtract the midnight, which is -4. So that's it for this section. Let me know if you have any questions.